I don't have the.
You don't have a pen. That's right. Ooh. All right. So these are the notes that we're looking at. Lesson 3, where we're solving systems of inequalities. Now, back in Unit 2, we did graphing of inequalities in two variables. And do you remember what was different about graphing inequalities versus graphing equations? What was different about them? Go ahead.
Equations have an equal sign and inequalities have less than or equal to or...
Yes, so the equations have an equal sign. An inequality has a less than, greater than, less than or equal to, greater than or equal to. How did that look different on the graph? Go ahead. Absolute values had a vertex. So that was the difference with absolute values, and linears are lines.
Equal to has a solid line and not, or less than or greater than have a dash.
Yes, so there is a difference between solid lines and dashed lines now, where equations are always solid lines. If it's a less than or equal to, greater than or equal to, you're going to have a solid line. Less than or greater than, we have a dashed line. What else? Go ahead.
There's a shaded sign.
There's a shaded section because a region is our solution, okay? Whereas when we are referring to an equation, the line is our solution, right? So when we did systems of equations, we had two lines. The first line, any point on that line was a solution to that equation. The second line, any point on that line was a solution to that equation. But to be a solution to the system, it had to be a solution to both lines. So the point where they crossed was the only solution that was a point that was a solution to both equations. So we're going to be doing the same idea, but today we're going to be doing it with inequalities. So today we're going to work on to solve. Our goal will be to solve linear or absolute value, because we've been working with both of these. Inequalities. And in order to solve them, what we're actually doing is we have to graph them. Okay, because our solution is going to, again, be a region like it was before. So our first example is y is greater than negative 2x plus 6. And then my other equation, or I'm sorry, inequality is going to be y is less than or equal to 1/2 x plus 3. Now, I have to go about graphing these. So y is greater than negative 2x plus 6. When I go to graph that, I'll just make these go up by 1/2. On both the x and the y. And when I go to graph this, I'm going to graph the point 0, 6 first, because that's your y-intercept. And my slope from there is going down 2, so 5, 4, right 1, so right to the 1. Down 2, right 1. And as soon as I get as many points that will fit, what I'm going to do is I'm going to use my straight edge to connect those points. Now, with this one, will I connect it with a solid line or a dashed line? The first one, greater than, a dashed dash, not solid, because I'm not or equal to this line. I am strictly greater than. So now how do I know if on that line I shade up or down? Y is by itself, so I can take any point, and if I'm looking for y values, the y goes up or down. Where is y greater? Up, or is y greater down? Is y greater when you go up, or is y greater when you go down? Up. So since y is alone, we know that y is greater when you go up. Y goes up and down, and that's why we like it when y is by itself, because we know we're going to shade up. I'm going to put the arrows on there, but I'm not going to actually shade my graph yet. Okay? This is why I told you it was really important that you know how to put the arrows on there, is for this section specifically from way back in Unit 2. I explained that you'll want to put the arrows on there, but don't go right to shading. Okay, the arrows are going to be very useful. Okay, now we have to graph the other one, which is graphing y equals 1/2 x plus 3. So 0, 3 would be our y-intercept, and our slope tells us to rise 1, run 2. So up 1, right 2. Now with this one, whereas before we were like all disappointed if it didn't cross in a nice spot because we wouldn't be able to solve by graphing very well. But in this case, it really doesn't matter where they cross at, because that's not the solution. Where they cross is not, I mean, it could be part of the solution, but it's not necessarily a solution. This one says less than or equal to, so I'm going to connect it with a solid line. All right, now, y is less than or equal to. So where is y? So I'm going to put my pen on a point. Where is y less than or equal to this point? Y goes up or down. So is it up or is it down where y is less than? Down. So I'm going to go to all the points here. And on the last quiz where you had this, some people drew their arrows on an angle. And I wrote, angles never go on angles. They go either up or they go down. Okay? Unless it is a vertical line, and you can't draw the arrow going up or down because it would just highlight the line, right? And then it would be x equals, so x is the only thing that goes left or right. Okay, but we always want to look at y, and if you're not sure, plug in a point, like 0, 0. See if 0, 0 works, and if it does, shade in that direction. If it doesn't, shade in the opposite direction. Okay, now this is where our Post-it notes come in handy, and I will come around and give everybody 2 Post-it notes who wants one when we start on our assignment. But what we're going to do is, we do not shade on this side of the pink line, so we cover it up. We do not shade on this side of the blue line, so I cover it up. So that I'm only looking at the arrows, because that's the way that I'm going to shade. That's where those shadings are going to overlap. So that's where I'm going to shade. This is my solution. And then it makes it super easy to shade it, because you don't have to color in the lines. And when you remove those Post-it notes, voila, your graph looks beautiful. We don't even have to practice what you learned in kindergarten, coloring in the lines. Cool? Now, I'm going to show you what this would look like if you colored everything in. If we would have shaded, don't do what I'm doing. Okay, I'm just going to show you. So once you have this, put your pencil down. If I would have colored the blue above, I would have done it really, really lightly. And the blue would have been all above there. And then what I would have wanted, I would have wanted pink below this line. And since I want to know what the solution is to the blue and the pink, I would have looked at the region of the graph that had blue and pink on it. This would have been the region to have blue and pink on it. So I would have said, this is my solution, and that's what I would have highlighted and colored very nicely for my final solution. If you put the arrows and use Post-it notes, it's a lot easier to get the answer without having all these different colors on your graph and getting confused as to what is your actual solution. Does that make sense? So, I only want to see your actual solution shaded. I want it to be very obvious where that solution is. So if you had to shade everything, it should be extremely lightly, except for your actual solution. Like you can barely see on here. If you look at my paper, you can see that this is a little bit pink, this is a little bit blue, but it's hard to even see it on the screen because I did it ever so lightly to see that this is obviously my solution. Okay, now is 2, -3 a solution from the graph. So let's look at that point, because that's what it asks us over here, is 2, negative 3. So write 2, down 3. Is 2, negative 3 a solution? If we're looking at the graph, we find the point. Is that a solution? No, because it's not part of the shaded region. Okay. I can see that it's part of one of the shaded regions, but not part of both of the shaded regions. So it's not in the shaded region for both inequalities. So it is not a solution. Okay. If I didn't have the graph, what I would have to do is I'd have to take the first inequality. So we'll take the blue one first. And my y value is negative 3 is greater than negative 2 times the x value is 2 plus 6. Okay. So if you're asked to explain this on a quiz, some people they did it and then they didn't know how to explain it. Like they did this work. If you're doing the work, your work is your explanation. If you want to use the graph, you have to give me a sentence as to why it is or is not. Does that make sense? But obviously, if I'm showing my work and then I answer yes or no, that is your explanation, is your work. Okay, so on the left side, I don't need to simplify that because it's already simplified. On the right side, I'll need to simplify that. That is negative 4 plus 6, which is 2. Is negative 3 greater than 2? No. So as soon as I answer no, I know that this is not a solution. Now, let's say I answered yes. If I answered yes, I'd have to move on and plug it into the other inequality as well to make sure it's also a yes. In order to answer yes, it has to be a solution to both. So you need to show me that you plug it into both. If you plug it into the first one and get a no, stop there. You don't have to waste any time. Does that make sense? Okay. So we'll write that down so that you know what you're looking for. So you have to get yes to both inequalities in order for the point to be a solution. All right, so our next example, x is greater than or equal to 2, and then y is going to be strictly less than 10. So I'll start, we'll put some scales on our graph. Maybe I'll go by 2s here. I'm going to zoom in on the graph. This is what I have so far. How do you graph x equals 2? It is a vertical line. So I'm going to have to draw a vertical line. This goes through the x-axis at 2. Now, wait a minute. Is it going to be a solid line or a dashed line? So I don't even have to put points on this. A solid. So I'm going to go draw a vertical line through the x-axis at 2, and that's a solid line. So I'm going to draw the solid line. Now, this is where I was saying this is the only time, because x is alone, that you draw your arrows going left or right, because the x-axis moves left to right. So where is x greater? Is x greater to the left or to the right? To the right. So these arrows are going to be going to the right. I'm just going to put lots of arrows on here so I can see that it's going to the right. All right, y is less than 10. What kind of line is y is less than 10? What kind of line though? Is it going to be, what does this line look like? It's going to be horizontal. Am I going to draw it solid or dashed? Dashed here because it's y is less than. So it's a horizontal line. Here's 8, here's 10. I'm going to make that line dashed. So there's the line. It's a dashed horizontal line through the y-axis at 10. Okay, now since y is alone, my arrow has to go up or down. Where is y less? Down. So on these ones, I'm going to be going down. Now here's where the Post-it notes come in handy. On the green line, we're not going to shade on this side, so I have to be able to see the arrows. That's going to be shaded. On the blue line, I'm not going to shade over here, so this needs to be shaded. Cool, I don't even have to color in the lines because I can see. Here's my solution. Oh man, I do have to color in the lines a little bit. I think I can handle that much though. And then I can remove my Post-its, and voila, I have my shaded region. Okay. The reason why I'm teaching you to use the Post-its and not multiple colors is because eventually we are going to have 3 or 4 lines on one graph. And if you have 4 or 5 colors on a graph, that's going to get super confusing as to where is all the overlap. If you use the Post-it notes, it makes it very obvious as to what needs to be shaded. So if we practice that with this, then in the next section, when we add another line or another 2 lines to the graph, it won't be too overwhelming. Okay. Are we okay with this one? All right, let's flip it over then. All right, so quick recap on absolute value functions. Okay, our parent function is if there's nothing else other than the absolute value of x. Okay, that's the most basic version of this function. Let's go ahead right now. All of these scales, we'll just put them as 1. So I'm just going to label all scales right now. So that way it's done. So I used scales of 1. I went and labeled all of them so we can do a quick recap on absolute value functions. Starting with the parent function. What do we know that this graph has to have on it? Because it's absolute value. Absolute value. What do those graphs look like? Are they lines? Well, kind of. They're a V. They're basically 2 lines, right? They form a V, okay? Or they could form an upside down V that looks like a mountaintop, or kind of like the A in absolute value. Could look like the A, or it could look like the V in absolute value. That's kind of your clue. Okay? The absolute value here, that's the parent function. Where's the vertex of our parent function? At 0, 0. It's always going to be at 0, 0. You could plug in your x values here. If I plug in x is 1, what's the absolute value of 1? 1, so y would have to be 1. If I plug in 2, what's the absolute value of 2? So I would have 2, 2. What would be the absolute value of 3? 3. What's the absolute value of 4? 4. So there's half of my V. I know that has to be the vertex. What's the absolute value of negative 1? 1. What's the absolute value of negative 2? 2. And you can see the pattern from there. So you could have made a table to do this, or you just know that your parent function has up 1, out 1, up 1, out 1 as the pattern from that vertex, which is at 0, 0. Okay? What happens when there's a negative in front of the absolute value sign? It's going to be, the V is going to be upside down. That's when you have that A. So this one's very similar to our parent function. That vertex is still at 0, 0, but instead of going up 1, out 1, up 1, out 1, it's going to go down 1, out 1, down 1, out 1. So there you go. Down 1, out 1. There we go. And we have the upside down version of the V when that negative sign is in front of the absolute value bars. Now this next one, we need to locate the vertex. How do you locate the vertex? Yes, set the inside of the absolute value bars equal to 0 and solve. So I know my vertex is at -2 for the x. I'll have to plug that in to find the y value. 2 times -2 is -4. -4 plus 4 is 0. I should get 0 for the absolute value because I set it equal to 0. I found the x that made it 0. So that turns into 0. What's the absolute value of 0? Still 0. 0 minus 3, -3. So there's my vertex. -2, -3. That's your vertex. Now, looking at that equation, is our V going to open up or is it going to open down? Is it going to be a V or the mountaintop? That's going to be a V. There's no negative in front of that absolute value. Okay? The number in front of x or the number out front, either one, is going to tell us that slope of the V. So this is going to go up 2, out 1. And there's my V. If you wanted to, you could have at that point made a table if you're more comfortable doing that way. If you're not sure, always refer back to making a table. On the last one, we again have to find the vertex. So set the inside of the absolute value bars, which says x minus 1 equal to 0, and solve for x. X equals 1. Our vertex then is at 1 comma what? We'll have to figure it out. 1 minus 1 is 0. I should get 0 in there because I found the number that made it 0. That's why I set it equal to 0. The absolute value of 0 is 0. But what's 0 times 2? Still 0. What's 0 minus 3? -3. So my vertex is at 1, -3. I go right 1, down 3. Again, the number in front of x or the number in front of the absolute value is going to tell me my slope. My slope here is also rise 2, out 1. So I'm going to have a V. How did I know that this was going to be a V and not a mountaintop? There was no negative in front of the absolute values bars. So that's a recap on graphing those absolute values, because today in inequalities you'll also have to graph those absolute values. So example 3 has an absolute value for the first one. I'm going to go ahead and slide this. Is anyone going to freak out? Freak out? No? Okay. All right, example 3. We are going to work with this absolute value one first. My vertex I need to find it. So I'm going to take the inside of those absolute value bars. 2x plus 6, set it equal to 0. What do I get for x? Go ahead and solve that now. What are you going to get for x? I did not get 3. Negative 3. Yes. Okay, sorry. Negative 3. Yes, x is negative 3. That tells you the x value of your vertex. Let's plug that back in. Once you plug it in, hopefully for the inside of the absolute value, we get 0, because that's what we had set it equal to. So 2 times negative 3 is negative 6. Negative 6 plus 6 is 0. Good. That's what we were supposed to get. What's the absolute value of 0?
0.
Make it negative. Still 0. The opposite of 0 is still 0. 0 minus 2 is negative 2. So I know that that's where my vertex is. Now, what does this V look like? Is it a V or is it a mountaintop? It is a mountaintop. So that 2 tells you it's not going to go up 2 out 1, but instead it's going to go down 2 out 1 because it has to be that mountaintop. So let's put our scale on here as 1/2. So every other one will be 1. 1, 2, 3. And then I'm going to plot that negative 3, comma negative 2. Which is right there. And then my slope set, I'm going to go down 2, out 1. So down 2, out 1. Down 2, out 1. Down 2, out 1. Now, this upside down V, is it supposed to be a solid V or a dashed V? Solid, because it's or equal to. So I am going to connect this with a solid line. And now y is alone. So is y less? Y goes either up or down. So where is y less? Up or is it down? Down. So from all those points, I'm going to draw arrows going down. All right, x is less than or equal to negative 3. This one is that vertical line. It has to go through the x-axis at negative 3. Is this a solid line or a dashed line? This one's solid because it's or equal to. So both of these are solid lines. Now x is the only one we do this for because x goes left to right. Where is x less? Is it left or right? Left. X is less when we go left. So I'm going to put all my arrows on here. Now I'm going to take my Post-it notes. And you might need 3 on this depending on where that V you have to go. But if I do my vertical line first, then I only have to do this portion of that V. And it's actually going to be this triangle that goes on forever down here. And there's my solution right there. So let you guys finish that up. If you're done, you can start putting scales on the next graph because we're just going to have a scale of a half again, just like we just did. Say some people are already moving on, so we'll get going on this one. All right, so we have to find the vertex because, again, we have an absolute value. So we know that this is going to have a vertex. Now, is that V going to be an upward-facing V, or is it going to be an upside-down V and look like a mountaintop? It's a regular V, yep, because there's no negative in front this time. So we're going to find the vertex. You're going to set that inside equal to 0. 2x equals 0. What does x have to be? X has to be 0. Plug in 0. 2 times 0 is what? 0. What's the absolute value of 0? 0. Good. That's what we needed it to be. 0 plus 3 is 3. Our vertex then has to be at 0, 3. Right there. Oh, I lied. I didn't want to go up by halves on this one. Otherwise, we're going to run out of room because we have to go up. So on your Y scale, go up by ones, not halves. I lied on that. Sorry. Actually, all of this scale will just go up by ones. Then 0, 3 will be there. We could have done it the other way, but we would have kind of ran out of space and it would have been no good because you wouldn't be able to see what we need to see here. Okay, so once you have your vertex on there at 0, 3, that slope is 2, okay? So it's going up 2, out 1, up 2, out 1. So from that point, from 3, you're going to 4, 5, out 1. Up 2, out 1. Up 2, out 1. Now, is that going to be a solid V or a dashed V? Solid, because it's greater than or equal to. Now, since y is alone, it says y is greater. Where is y greater? Up or down? Up. So from all those points, we're going to have to shade up. So I'm going to draw my arrows going up. Okay. Not shading yet, though, because I'm going to wait till I have both my lines on, or both inequalities graphed, and then I'll shade what I need to. Okay. Y is less than 2x minus 5. Now that's linear. What's the y-intercept? Negative 5. So 0, negative 5 is there. My slope says 2 over 1. So rise 2, right 1. Up 2, right 1. I'm going to put as many points that will fit on my graph. It's important that you graph on the entire graph that's provided. And once you have all of those points on there, am I going to connect these points with a solid line or a dashed line? This one's dashed because it's less than, not less than or equal to. Now, this is y is alone. It says y is less. Where is y less? Up or down? Down. So from those points, I'm going to have arrows going down. All right, now I use my Post-it notes. And I'm shading this way on the V. But wait a minute. I have to cover up that side of my line. Where am I shading? What happens if you are looking at those arrows? If I cover everything up from those arrows and everything up on the offset of these arrows, what can I see on my graph? Nothing. If I cover everything up on this side of my absolute values, the whole graph down here is covered up, right? And now when I go to cover up on the linear equation, I can't even, or the linear inequality, I can't even see that, but I'm going to be covering up this side of it. And since I now have covered everything, there's no overlap and there's nothing to shade. The arrows are going in opposite directions. This would be blue up here, this would be pink. There would be no overlap on my graph. So because of this, no overlap means that there's no solution. So there's actually no solution on this graph. We just graphed that, but our solution's no solution. There are no points on this graph that is a solution to both the inequality that's the absolute value or the inequality that's the linear function. That is it for today.